Okay, class, picking up where we left off at, instead of me just reading it all to you, I actually typed it out here for the rules and words. So what you could do here, just for a couple seconds, you could just pause the video and copy down what these mean in words. Okay, now we're going to go to the rule with the symbols. We have the same base, we add the exponents. I'm going to write it over here to the side. We keep the base, and we add the exponents. Here we keep the base, and we subtract the exponents. Here we keep the individual bases, but we multiply the exponents. Now remember, these are assumed to be to the first power. You see how we jumped here. So it'd be 1 times n, which will give us n. And then 1 times n, which will give us n. We'll keep the base of nc, and the exponent will be n. Here the same thing as we did previously. Here, both of these are to the first power. So this will end up being b to the n over c to the n. Then finally here at the bottom, b to the m times n. We have a power to a power. We keep that base, and we multiply it. Now, it says all of the exponent rules apply only to multiplication and division. They do not apply to addition and subtraction, so you definitely need to remember that. Now we come down to example 6. Now, one thing that I need to let you all know that's watching this video, there was a question asked when I was waiting for the video to finish saving about what happens when you multiply bases that are numbers instead of the variables. You still follow the same rule. You carry over the base here is 4. And since it's multiplication, you would add the exponents. 3 plus 5, it would give us 4 to the 8th. Now, the only difference is this here. Because we have a number to this power, we actually can find the actual final value. So this is where you would basically take a calculator, and you would actually take this calculator. You would take 4 to the 8th power, and the answer is 65,536. And that will be your final answer. But you still must show this step as well. Now we come here to B. We have in parentheses, yes, I have a question.
So no matter what, you always just carry the base.
With these properties, yes, you would carry the base. Okay, now we have 3 times x to the 5th times y to the 2nd, all in parentheses to the 3rd power. We will put this exponent, this is really 3 to the 1st, so we'll multiply all of these exponents by 3 and keep the base the same. So this will become 3 to the 3rd, x to the 15th, and y to the 6th. Now 3 to the 3rd, we know is 27, so it'll be 27 x to the 15th, y to the 6th. And we're done with B. Now we scroll here to page 185. Now, we have here 5x, it says example 6. They want us to simplify this. Now this looks a little different than what we've covered, but it's still the same exact problems. So it's the same rules. Well, first of all, here in this parenthesis is taken to the 2nd power. So we have to do everything in this parenthesis first. So we can bring down this 5x to the 6y. Now in this parenthesis, we know this would be basically 3 to the 1st to the 2nd, which would be 3 to the 2nd, which is 9. We have x to the 3rd to the 2nd. We keep this base. 3 times 2 is 6. We have y to the 5th to the 2nd. 5 times 2 is 10. So that would be y to the 10th. Now we multiply. 5 times 9 is 45. X to the 6 times x to the 6 will give us x to the 12th. As we have the same base, we will add the exponents. Now this y is really to the 1st power. Y to the 1st times y to the 10th will give us y to the 11th. So this is our final answer. Now we come here to D. It says here with D, we have this parenthesis to the third power, this parenthesis to the fifth power. So we would take care of those exponents first. This would give us b to the 15, c to the 6, because power to a power we multiply. This will give us b to the 20th and c to the 40th. Because again, power to a power we multiply. Now, we will have multiplication here, same base. We add the exponents. 15 plus 20 is 35. C times C, this will give us C to the 46. And we're done. Now we come here to E and F. Both of these, if you notice, they're both division. So here we would start this off the same like we would do any other division problem. With the 12 and the 8, we can simplify 12 and 8. We know both of them has 4 in common. So we divide both by 4. That'll give us 3 over 2. Now we look here at these x's. If you notice, these two x's here, x to the third times x to the fifth, we could just combine them to one x, make this x to the 8th. Because that's what it really is. So now we have x to the 8th divided by x squared. This has a higher exponent than this does, so you know it will remain in the numerator. 8 minus 2 is 6, so it'll be x to the 6th. Now we come here to f. If you notice here inside this parenthesis, there's nothing we can simplify here. They have nothing in common. So the only thing we need to do is take everything in here to the 4th power. So we know a power to a power, that would give us x to the 20th. And then our denominator. Now, we know this would be 8 to the 4th power. So we need to take our calculator. We would take 8 to the 4th power. And that would give us 4,096. And then this y would be to the 4th power. And we're done. Are there any questions with that? Yes.
Okay, so for part E, why wouldn't the bases be the same? If for the property you say when the bases are divided, we just subtract the exponent.
Right, but see up here in our numerator, we needed to combine these two first because they had the same base. Because x to the third and x to the fifth combines to x to the 8th.
Okay, so what I'm saying is why wouldn't it still be the 12 over 8?
Oh, 12 and 8. Remember, they're just basically numbers. See, we could just divide this. This has nothing to do with the same base. Only time you deal with the same base with the numbers, it has to be the exact same number. You don't leave it 12 and 8.
Okay.
Okay. Well, unless you couldn't simplify it, then you would leave it as 12 and 8. Okay, now we go here to G. Now, everything in here is taken to the 3rd power, and you notice they have nothing in common here. So, we would do this. 4 to the 3rd power, we know is 64. X to the 7 to the 3rd will give us x to the 21st. All over. This would be 3 to the 3rd, which is 27. And then y to the 5th to the 3rd would be y to the 15. And this is w to the 1st to the 3rd, which will give us w to the 3rd. And that's it. Now we look here at h. Now with h, if you notice here, this parenthesis is taken to the 3rd power. So everything inside this parenthesis would be taken to the 3rd power. So let me just pull up this calculator so we can get this 7 to the 3rd power real quick. So it would be 7 to the 3rd power, which would be 343. So we had negative 3, f to the 4th, and then 7 to the 3rd is 343. F to the 2nd to the 3rd is f to the 6th. G to the 7th to the 3rd is g to the 21st. Now, negative 3 times 343, we know it's going to be negative. And when we multiply this, this will give us 1,029. F to the 4th times f to the 6th, same base, we add the exponents. That'll give us f to the 10th. And g, we have nothing else that matches up with g, so we'll bring g to the 21st down. Any questions on that problem? Okay, now we go to I and j. Now, with I here, everything is taken to the second power. But before we do that, unlike the other parentheses we've encountered with these fractions, we actually have things in common. So why don't we simplify first, then take everything to the second power? 6 and 8 both has 2 in common. So that'll leave us 3 in the numerator, 4 in the denominator. A to the 5th over a squared, we know that will leave us a to the 3rd. So now we have b to the 3rd, and c has nothing in common. So it's just b to the 3rd and c to the 5th will remain the same. And that's all squared. Now we square everything on the inside of this parenthesis. 3 squared is 9. A to the 3rd to the 2nd is a to the 6. B to the 3rd to the 2nd is b to the 6. 4 squared is 16. And c to the 5th to the 2nd is c to the 10th. And that is your final answer. Now we come here to j. Now j basically is a combination of just about everything we've covered so far. Now we have this parenthesis to the 3rd power, so we know everything in this parenthesis is taken to the 3rd power. So it'll be x to the 9th, y to the 3rd. We'll bring over everything else. Now, in our numerator, we'll multiply, and since they have the same base, we will add x to the 9th, x to the 4th is x to the 13th. Y to the 3rd times y to the 5th is y to the 8th. And that's all over xy squared. Now we can simplify this. They have the same base, so we will subtract the exponents. This will give us x to the 12th. And since this is larger, we know this will be in the numerator. Now we have y to the 8th over y squared. Since this exponent is larger, this will give us y to the 6th, and we will have nothing left in our denominator. So does everyone follow that? And that is the final answer. Are there any questions over section 7.4? Any questions? All right, well, we are done.